And they use a special type of crimper like this here. Okay, so I've started working on my electrical system. I built some more structure inside this part of here. So this just goes across, and as I said, I was going to support the weight of these struts here, so that we don't have a lot of huge heavy weight on them. So here I have, these are pushing down on that metal there, and it goes all the way across, and I have another bar in the back there that's supporting this part here so that it's not resting on nothing. Up on the top I have a bar going across the back that the batteries will push up against, and then individually I have 4 slots for them that will keep them separated from each other so that air can flow around them. Here I have a 3/4 inch plywood that my electrical is going to attach to, my components. Here's my components down here. It's just attached with a carriage bolt coming through here, and then a nut on the back of it. It's not tight yet. So now it's just, I've already placed them outside on a table just to make sure that everything fits, and then I'm going to place these in here and screw them to the board. I'll explain the flow of it all once I get them put together. One thing I would recommend if you are going to do your own electrical is to use ferrules. These are ferrules. These are for 8 gauge. They use a special type of crimper like this here. The ferrule goes in there, and then it basically creates a squared off connection like that, so you don't have a bunch of frayed wires. And when you stick them into those where they have the little screw down on top of it, you're screwing it onto this hard connection instead of squishing the individual wires out. It's safer because you don't have a chance of one of these little wires getting out and touching the other side and shorting your system out. So anywhere where it's going to screw into a component, I use these ferrules, and then of course lugs. Okay, so I just wanted to go over some of the tools that I'm using. So I have just a pair of wire cutters, small, and I use these mostly for cutting zip ties in small tight places. These are also like a cable wire cutter. These work really good even on large 4/0 cable. Some wire crimpers. This is a smaller gauge wire crimper. This is a large gauge crimper that goes all the way to 0 gauge. And then for 4/0 and larger ones like 4/0, I use this, and I'll show you a demonstration of how that one works. You need like a 3-pound sledgehammer to use this one. You need wire strippers. So this is for my smaller gauge wire strippers. You just put it in there and clip. That's like an old school model. This is for larger gauge. I've tried it on like 8 gauge, but it doesn't work as well. It's like not enough pressure, but for 4/0 it works really good. With the kit that I bought from FreedomVanGo, they send you a couple Ethernet cables, but not too many of them. Most of it's just a wire, and you have to put on your own end caps, or just buy separate ones with it. But it does come with the wire and the connectors. And so this is a Ethernet cable wrench, and then you would need a cable tester as well if you're going to build your own cables, because you want to make sure they work before you stick them in your system. And also some way to heat shrink. So I prefer a gun over open flame, because open flame generally you can do too much and you can start melting insulation, and it's a little easier to control with a heat gun. It doesn't have to be a fancy one. This is a Milwaukee, but you can get one from Harbor Freight for pretty cheap. So with wiring, you typically have 2 two different types of conventions. So in DC, which is called direct current, black is typically your ground and red is your power, your positive. With AC, black is your line, which would probably considered positive. White is your neutral, and then green is the ground. So the color of the wire is really the only difference. There's nothing special about a black wire and a red wire that separates them. So it's best to just stick with convention. Always use red for power, for positive, and ground, black for negative on DC, and then always follow this same convention for AC. So black is your line, white is your neutral, and green is your ground. That just avoids confusion. So like a lot of your components, like with DC, they're going to come with that convention where red is positive and black is negative. So if you mix that up, nothing would prevent it from working if you did it right. Like if you put a red wire in here and then hooked your red wire up to your negative, it would still work. But keep it within the same convention so that you're not mixing things up. Especially if somebody else is going to later buy your van, you don't want to create confusion by doing something weird. I also recommend for anything going through walls that you include tubing to protect them. So like things like this are very sharp, and then over time as your wires across it, it's vibrating, and so you'll wear out the insulation on it and eventually you'll get a short. So it's best to protect them with some kind of flex tubing. So I thought I'd show you how the ferrule works. So here's one that's uncoated, so you can see what would happen is if you're pushing a screw down on that, it tends to flatten out and you get splay. Plus it's possible for these little individual filaments to come out to the side and possibly short out your system. So with the ferrule, you just put it on, and I usually like to twist with the grain like that. Then you take your crimper and push it right up against there. And now you get a nice square, flat, extremely sturdy connection. So this is my current electrical setup. It's mostly complete. I'm just waiting. These are my batteries here. These are Victron 200 amp hour batteries, and you can see they're pretty small for a 200 amp hour. This is not much bigger than a 100 amp hour Battleborn. It is expensive, so it's more than buying two 100 amp hour Battleborns, but it gives you this nice compact form factor. So if you want to put a lot of battery power in a small space, this is the way to do it. They have these connectors, so you build these or attach these in, and one end will go down to the main control unit, which I'll show you later. I'm currently waiting on extension cables because it won't reach from here all the way to there. These are my main power lugs for when I'm ready to hook everything up. I won't do that until I get this that extension wire. Basically they come through here. I've made both of these cables, the positive and the negative, the same length, even though one will be here and the other one will be over here. I'm going to hook these up in parallel, so it'll be a 12 volt system. If you hook them up in series, then this would make a 36 volt system. In series they add in voltage, but they don't add in amperage, whereas in parallel they add in amperage but not in voltage. So a 12 volt system would be a 12 volt with three 200 amp hour batteries makes a 600 amp hour 12 volt system. If they were in series, it would be a 36 volt 200 amp hour system. And there are reasons for doing either way. It's probably easiest in a van to do it as a 12-volt system, but the downside is that you're going to have larger wire. So your wire is always gauged according to the amperage that's flowing through them. So the more amps you have, the bigger the wire's got to be. And I think this is the biggest wire that I've seen most people use. This is 4/0, so it's very thick, very heavy duty. Also, if you did this as a 36 volt, you would have to step it down for all your 12 volt systems. So you'd need a DC to DC converter to drop it down to 12 volt, because most of the stuff that's available, like refrigerators and lights, they're all 12 volt. Okay, so the basic layout of the system, this one is like the main brains of the system. That's their BMS. So the batteries will plug in here for these little control cables. They plug in here, and on the end here we have these, it's called a battery protect here, and then there's another one here. And what those do is they cut off inputs to whatever they're serving, or outputs. So this one is serving my chargers, and it talks to that BMS, and so when that BMS says these batteries are full, this will shut off and it will not allow current to flow through into the bus system. The other one is this one here. This one's feeding the DC power panel. So what happens with that one is, if the battery gets so low that it's going to damage the battery, this one will shut off, and they both connect to this. For my charging options, I have my MPPT charger for solar. This is a 30 amp. It's a little underpowered for what for my solar system, because I have 700 watts of solar. It can be upgraded, so you could just take this out and put in a bigger one. I have two 30 amp DC to DC chargers. These are my Linx power distributors. They're like a fancy bus. They have a little, let me open one up here. So these are the Linx power distributors. So they have a positive bus bar and a negative bus bar, and then these are grounds. So this is just basically sending my MPPT ground point to the ground bus of the distributor. And then off this main one here, I have a ground, a big huge ground that will go to the inverter, which will then go to the van ground. So the way these work is, you have a blade fuse right here. It's one of these larger ones that connects the bus bar to the positive of whatever you're connecting it to. And then underneath here, this is removable. So these can just pop right off. So this is your negative, and this is your positive. And then each one is a separate circuit. They come with this little plastic piece here in the middle. I'm not sure why they do that, but you just basically just twist it and it comes right off. And then these isolate the ground wire from the positive bus bar wire. They hook together. They have these mounting points right here, and then the other end has two tabs that just stick out, so you just basically pile them on. They also sell a large BMS. It's pretty expensive though, and I bought this system from Nomadic Cooling. They have it on their website, but they actually just farm it out to FreedomVanGo. So you can buy the same system on FreedomVanGo's website. It comes with pretty much everything you need. I've only had to buy like a few, like some more 4/0 cable and maybe some connectors. But other than that, it seems pretty complete. The advantage of buying it from them is you don't get halfway through your electrical build and realize, oh, I need this, and now I gotta wait for this to be shipped to me. So it is, I did price it out, and it seems like it's pretty much just the sum of the components cost. So it's not really costing you more money to do it that way. The only downside is you may get components that you didn't want, like maybe you didn't like this kind of fuse box and you wanted something else. But they have everything in there that you need. I did have to buy one of these. This is a 4-post ground, and I bought 2 of them because they had one that was just like one little post, and I think I have too many things, so I bought this instead. So basically the way I have it up here, this is my AC. So this one has a 80 amp fuse, and this runs to the main power of the AC. This is my inverter. So my inverter is a 3000 watt inverter from Victron, and I'll show that when we get over there. This goes to my sub panel for DC. This is my power input from my 3 charge sources, the 2 DC to DC and the 1 MPPT. On this one, the reason I have 2 of them is because I'm going to put another sub panel in on the other side of the van, so that all I have to do is run 1 wire across the roof of the van to the other DC sub panel, and then I can just run everything on the other side of the van off of that. These are fuse boxes, so I've got 3 inputs, and it's the same type of blade, it's just smaller. So each one of these is fused inside here, and these 4 little clips here open up, and then you can access the fuses. And they even have a place inside these to hold a spare fuse. So each of these is fused with a 60 amp fuse, and then they all combine into this one output, which then comes back into and feeds the battery for recharging. This one here is from the alternator. So the wire will come through here and go up. I haven't run the wire yet, but it comes through here and it'll connect the positive here and the negative to this bus bar, and then that feeds the 2 DC to DC chargers. It'll have to be a large gauge wire, probably 2 gauge, to get all the way from the alternator back to here. Over here I have the smart shunt. This basically communicates with your Victron components to show you the charge status and how things are flowing through your system. I have a large on-off switch here. The VE bus mains detector, I think it just tells the inverter that there's power available. There's another component here. Smart dongle. This one is just a Bluetooth. Gives that Bluetooth capability. And that just sticks on there. I need to get a better Velcro, double-sided tape to hold it on there. Let's see what else. These small control wires, like I said, they're used by the BMS to tell when to turn this on or off, so that you don't get overcharging and that one over depletion. I think that's it for the summary of the system. I don't think I've missed anything. For the wiring, I've just used these cable tie. They're designed to hold it to your wall inside your house for cable TV. And it's just the right size for this 8-gauge wire, so it allows everything to kind of stay in place. You also use small zip tie to keep everything from like getting tangled up or stuff. All right, here's the inverter mounted up. It's a 3000 watt inverter. On the 8020, I put some carriage bolts, and then I use a Forstner bit to create the larger hole and then drill out the center. And I did that on 4 points. So it's all mounted up there nice and tight. And then you mount the bracket. So what I did is it has a lip on it that has to go. So say this is your bracket, there's a lip that you have to go up and over. And so when doing the height of it, I measured from, if I took the bracket and put it right on the top of the lip and then up, that's 2.5 inches, so I went 3 inches, so that gives me room to go up, back, and down. Without that, you won't make it if you have a top like this. So here's a sample of the bracket here. So you've got 5 screws here that'll go into, in my case, my plywood. And then this is what I was talking about here. I set the bracket on the top of this and the bottom of that, and then measured this distance here. And that was 2.5 inches. So I went 1/2 inch more just so I have a little room to go up and over that lip when I'm placing the main unit in. Okay, so in order to hook up the inverter, you have to take the front panel off. It's just 4 little screws. You have 3 ports here. One is a AC in, AC out. So this would be like for your shore power. AC out, there's AC out 1 and AC out 2. And then here's your main battery inputs. So, and then there's a little slot here for the large gauge wire to come out of. And then that, for me, that'll go up and around and then down to my Linx Distributor. So this one is going to be for my mains, my 120 volt main. Here's my panel here. This also came with the kit. They also have some fans that you can mount here that'll draw air across the system. I'm going to have the mains probably here and maybe put the fans up in this area just to create airflow. This is the main power from the Linx Distributor, and then the main ground is down back there, and then that will, I'll have to put another 4/0 cable on that, which will come to some piece of strip bare metal on the van. So inverters, if you can afford it, I would always go with a pure sine wave. It's better, it more closely mimics AC that you have in your house. And so any device that's really sensitive to how the waveform looks is going to not work with a modified sine wave. I can go over this in more detail if there's interest for it. But basically a modified, it's more like going like this, whereas a pure sine wave looks more like a nice curve. And so things like induction cooktops are going to require a pure sine wave. They won't work right. They may work, but most likely they won't work with a modified sine wave. You need pure sine wave. So for cutting large wire, I really like these here. I'll put a link below where I got them off of Amazon. So when you're cutting this 4/0 wire, it can be kind of tough to get through it. But one thing you can do, I mean, this one's pretty easy because it's copper, is just put it between your knees and use your knees to help clamp it shut. It's really easy. Okay, so this is my tool for crimping 4-gauge or 4/0 wire. So here I've got a piece of heat shrink, and then I've cut it back enough to fit the lug. Here's the lug. So basically you just want to put the wire in there, try and get all the strands in there. It's not imperative if you have a few that are stray, just as long as you cut them off so you don't create any potential for short. And then you want it to be right up against the insulation so that the size is just right. And then this thing, it just pops up like that. You put your lug in there, get it nice and tight up against the lug, and then take a sledgehammer. So I just have a little 3-pound sledge. Just give it a few taps. That's probably good. It is possible to hammer it too much and then it gets stuck in there, and so you have to kind of tap it out. But you can see it has nice crimp on there. It's good and tight. And then you want to put your heat shrink on before. It's still possible to get it over the lug if your heat shrink is big enough, but if it's kind of tight, it might make it difficult. And now for the heat shrink, I just use a heat gun. Generally, it's better to use a heat gun instead of fire. So like from a torch or something like that. I know I see a lot of people using a torch, but it's generally considered better to use a heat gun because you don't risk melting through. I used to work on airplanes, and using open flame was always considered bad for heat shrinking wires. So we always had a heat shrink gun specific for that purpose. And it doesn't have to be a fancy one. You can just get it from Harbor Freight. Sometimes cheap. And just kind of heat it up all around, all sides, so it closes up on it. There you go. So basically that's it. I apologize that this took so long. Mostly it's just me trying to get a good grasp, understanding the system and what I'm doing. I did used to work on F-14s when I was in the Navy like 30 years ago, but it's always good to just take your time, understand what each component is doing, follow the schematic. So FreedomVanGo provides a schematic, and it includes all of the gauge wire that you need. They also are very good with answering customer questions. So if you have questions about something, just email them. Same with pneumatic cooling. Take your time, work on one system at a time. So separate all your inputs, figure out how that works. Go to your outputs, figure out how all that works, how it's wired up, and then your distribution buses, and just arrange all your components on the size panel. I mean, the amount of components you have will determine how much space you're going to need. I mean, you can see I'm pretty, this is about 50 inches wide, 54 inches. So it takes up a lot of space if you have a lot of components. There are simpler systems out there if you're rolling your own. I know Will Prowse, he has a lot of good stuff. Most of his is older. He's not as excited about doing van videos anymore. He's mostly in the big solar stuff, but his information is still good and it's still valid. I like components that are all matched. So for example, I have all Victron, everything is Victron. The advantage of that is if something goes wrong, you don't have one vendor blaming the other vendor. So Battleborn, I mean, they wouldn't do it because they're a Victron company, and they're very good with customer service. But if you had one type of battery, like a sock battery, you know, they're not gonna, they might blame your system, Victron components, and then Victron might blame the sock battery company. So you're dealing with two companies fighting with each other, trying to push you away so they don't have to fulfill a warranty claim. Whereas if everything you have is Victron and it's from a reputable company, you're pretty much guaranteed to get good service from them. So that's it for now. Like I said, sorry it took so long. It's just I want to be sure what I'm doing, especially with electrical. Just take your time, do it right, don't do any shortcuts, follow the schematic, and if you have questions, ask somebody. And if you're not comfortable, just have somebody else do it for you. You can do part of your build yourself, and the things that are scary and you don't want to touch, just have somebody else do it. Another good option, if you want a really cool power system, is Ecoflow. They have a brand new all-in-one built-in system that you can just basically plunk that thing in there, and it's got your inverter, it's got huge power. They're linkable, so you can put multiple ones together. And their newest one also has a charge port that you can hook up a electric car charger to it, and you can charge it with that really quick. So something like that would be really cool. If you're traveling around and your battery's depleted and you need something really quick, you just pull up to a power station and plug in your van battery into a car charger, and it'll probably be charged up within an hour. So that, if they came out with that after I bought this system, but if I had had that, I might have actually just gone with that instead of trying to roll everything myself. And it's actually fairly cheap. I mean, they have a, I think it's a 300 amp hour system for $2,300. You know, and you put two of those together and you have what I have. So yeah, there's lots of options out there, and it doesn't have to be difficult like this. But like I said, at the time I bought it, they didn't have that out. The other disadvantage of them is their warranties aren't as long. So like Battleborn battery has a 10-year warranty on it, whereas like a Yeti battery system is only about 2 years. Now, if you don't plan on staying in your van for 2 years, or you plan on selling it or just using it occasionally, it'll probably be fine. All right, that's it for now. Bye.